Question 10. The formation of half mole of A2 plus 2 moles of B2 plus 1 mole of C produce CaB4 has an enthalpy of formation of negative 100 kilojoule and a change in entropy of negative 0.06 kilojoule per Kelvin at 27 Celsius. What is the free energy, delta G, and spontaneity of reactions? So the reaction will be spontaneous reaction if delta G is negative. So now you have to calculate delta G. Delta G equal delta H enthalpy minus temperature times entropy. So here enthalpy negative 100 minus temperature, it's in Celsius, it must be in Kelvin. So what is the relation between Kelvin and Celsius? Kelvin equal 273 plus Celsius. So here you add to add 273 plus 27, which is equal 300 Kelvin. So here the temperature is 300 times delta S negative 0.06, which is equal negative 100 negative 300 times negative 0.06 equal negative 18. So here negative 100, negative sign with minus here, plus sign, so plus 18, which is equal negative 82 kilojoule. And because the charge is negative, so it's a spontaneous reaction. So the answer is negative 82 and spontaneous reaction. So the correct answer is A. Now question 11. Which of the following processes will lead to a decrease in the entropy of the system? Here, salt crystals dissolved in water. If you remember from the handout, an example of increasing entropy dissolving in water. So this is an example of increasing entropy. Why dissolving in water? It's an example of increasing of entropy because here salt crystals means the state is solid, and dissolved in water the state is AQ, which is liquid state. So when substance changed from solid to liquid, particles in liquid state become more free to move, so more randomness, so increase entropy. Now air escapes from a hole in a balloon. When air escapes from a hole in a balloon, so they become more free to move. So it's an example of increasing entropy. Now see, iron and oxygen react to form rust. Here you have two substances produced one substance. And here iron, the state of iron is solid, plus oxygen, the state of oxygen is gas, to produce rust, iron oxide, which is a solid. And if you balance the equation, here by 2, by 3, and here by 4. So here in the reactants you have gas state, and in the product solid state. So here particles are free to move and less ordered, and in solid particles they are more ordered. More ordered means less entropy. So the question asks which of the following processes will lead to decrease in entropy. So this is the correct answer. Now question 12. Any reaction will be spontaneous if we talk about Gibbs free energy. When it's negative, so the reaction is spontaneous. So when delta G is negative. Now question 13. Predict which of the following reactions has a positive entropy. Positive entropy means increasing entropy. So if you have chemical equations, first you have to check state of substances, and if they change from solid to liquid to gas, it's an example of increasing entropy. If the reverse, decreasing entropy. And then you have to check number of moles in reactant and product. So if all states are the same, if all states are the same, for example, gas, 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 or liquid, 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 so you have to check number of moles in reactants and products. If number of moles in products greater than number of moles in reactant, so it's an example of increasing entropy. So here, increasing entropy. If the reverse, so decreasing entropy. So again, this is a new idea. If you have chemical reactions and you have to get which of these has a positive entropy. Positive entropy means increasing entropy. So the priority first to check the state of substances. If the state of reactants is solid and the state of product is liquid and gas, it means increasing in entropy. Then if all states are the same, you have to check number of moles of reactants and product. So now what about these examples? Here the first one, all states are gases, gas, gas, gas. So if all states are the same, you have to check number of moles. Here you have 2 moles of N2 and 1 mole of water, so the total number of moles of reactants is 3. Now here you have 2 moles of product. So here number of moles of a product less than number of moles of reactant, so it's an example of negative entropy, because the rule is when number of moles of a product greater than reactants, it's an example of increasing entropy. Here number of moles of product less than reactant, so it's an example of negative entropy or decreasing in entropy. Now what about the second one? Here the state is solid, and here you have gas. So the state changed from solid to gas. Solid to gas, it's an example of increasing entropy. Now 3. Here you have solid and aqueous, which is mean liquid state, and here you have liquid state and gas. Also here liquid state, okay, but here solid and here gas. So changing from solid to gas. Solid to gas, it's an example of increasing entropy. So the correct answer is 2 and 3, D. Now, CE questions. The melting of ice is exothermic reaction. No, from the handout, you can see that the melting of ice is an endothermic reaction, so it's a false statement. Now, delta S is positive for melting. Yes, why? Melting means changing of state from solid to liquid. So changing of state from solid to liquid, it's an example of increasing entropy. Increasing entropy means the entropy is positive. So it's a correct statement.